So great. Welcome again, everyone, to this presentation. And so I'll go ahead and just basically introduce myself. So I founded the InnoSoft a long time ago. It was, I believe, in 2008 in Dubai. And we offer consulting, research, and education in AI and machine learning. And we've successfully trained thousands of data scientists and AI professionals and software developers. So in the last 4 years, we have been focusing mainly on AI, machine learning, and big data. And I also founded one of the largest meetup groups in the UAE. You can just look it up. It's called InnoSoft Gulf AI and Big Data Meetup. It has about, like right now, nearly like 4,000 members. I lived and worked in the US for over 10 years, and I went to the University of Illinois there, and I worked for a couple of large companies while I was in the US. One of them is Sun, where I was part of a Sun architecture group, where we developed best practices on how to design object-oriented applications with Java. And I also worked in the Chicago Board of Options Exchange, where I had the opportunity to be a part of a team to build a system which was called SBT, which means screen-based trading, which enables traders to execute transactions after trading hours. Last year, I worked with a couple of teammates on a project at Stanford. Actually, I'm in a graduate program. So it was a self-driving project. Just look up my bio and you will see the PDF. You can download it if you would like. All right, so that's just a little bit about me. So I'll go ahead and proceed. So what are the learning objectives for today? I'm going to focus on just understanding some of the concepts around AI or big data. So we'll be talking about big data. We'll also be talking, obviously, about AI and what's the relationship between AI and data science. So we will try to clarify that. And we will also talk about some AI terminology. As we will see later, we will be talking about machine learning, about supervised learning, and so on. And also, we will cover like what's the difference between AI and machine learning and what makes an AI company. If you remember, in the old days, companies had to make transformations to become internet-oriented. And now many organizations are finding themselves in a situation where they have to make some kind of transformation to take advantage of the new tools that AI offers today. Also, we will try to demystify what actually machine learning can and cannot do. Some people, especially C-level executives, sometimes they can have unrealistic expectations in terms of what AI can and cannot do. So we will hopefully talk about that a little bit. One area of AI in the last few years, which has enabled rapid growth, it's called deep learning. And that's one of the technologies that has basically fueled several sectors like self-driving cars, anything that has to do with facial recognition or natural language processing. So we will have an opportunity to discuss what deep learning and neural networks are, and also if you have any questions about that, we can discuss that. You know, are there any guidelines that we can follow to build an AI-driven organization? Basically, that's the program for today. So let's go ahead and first talk about big data. The first question that we want to ask is, what is big data? And some people could possibly ask the question, well, we are talking about AI. How is big data related to AI? Well, the reality is there is no AI without big data. And it's worthwhile to take a moment to talk about what actually is big data. Typically, when we think about big data, we think in terms of the characteristics of big data. And one of them is the volume. One question that we could ask here is, how big is big data? So typically, when we have data in terms of terabytes or petabytes, again, terabytes is 1,000 gigabyte and a petabyte is 1,000 terabytes, then that's a situation where we are talking about a large amount of data. Actually, I have a friend, a data scientist in Boston, who handles every week petabytes of data. I believe he's working at a TV channel or TV station, and they have millions of subscribers, and he's capturing every single pixel that the users click on. So you can imagine that's going to be a huge amount of data. The other thing also that think about when it comes to big data is this idea of velocity. So velocity basically denotes the speed at which the data is generated. Last time I spoke to Mohammed, he said they have projects using IoT devices. So that's an example of a situation where you are getting a constant stream of data, sensors capturing data about different types of measurements like temperature, pressure, and so on. And based on that data, you want to make a decision like preventive maintenance decisions or things like that. If we have a huge amount of data like that, we need to think about where are we going to store that data and how are we going to process it. Okay, another characteristic of big data, which is also important, is called the variety. Obviously, when we are dealing with large amount of data, we need to think about what kind of data are we dealing with. There are, in fact, two types. One is called structured data. The other one is called unstructured data. So just to use the textbook definitions, structured data is the data that has a predictable format or schema, data that normally you will find in spreadsheets or relational databases like Oracle or SQL Server or even ERP systems, where basically the records, they follow the same structure. They can be like customer records or product records and so on. Whereas unstructured data is data that does not have a predictable format or schema. Examples of that include images, videos, social media content, articles, voice. And what we have seen in recent years, there's like an explosion of the amount of unstructured data that we have. In fact, unstructured data represents today over 80% of the data that we have as a human civilization. So for many companies, they basically woke up to the fact that, wait a minute, we have this huge amount of unstructured data that we can also get insight from. It's worthwhile here to basically pause for a moment and discuss what are some of the use cases that we can implement using unstructured data. For instance, I can mention one of our clients, Emirates Airlines. We worked with them a long time ago, and they had a project, or let's say they might have a project where the input would be social media content. In other words, what customers feel about a particular product or a service. It could be in the form of Facebook post or tweet. And then the output would be like classification, where we try to assess how does the customer feel about that particular product. Are they very satisfied? Are they satisfied or neutral, and so on? So again, the input is unstructured data, and then the output would be a classification that determines how the customer feels about that particular product or service. And this is basically called sentiment analysis, and it's a multi-billion-dollar business. Okay, one last point that I want to mention, or characteristics about big data, is called veracity. This is not a very common word, but basically it denotes how accurate the data is. So obviously, if we are working with data, we want to ensure that whatever data we are working with is accurate. Hopefully, it doesn't have any kind of bias, whether it's gender bias or racial bias or whatever the bias could be, because that's the data that's going to be the foundation of our AI system. As we will see later, that's how we are going to train our machine learning algorithms. Okay. So basically, that's just an introduction about big data. So the next step is to talk basically about what is artificial intelligence. As we will see later, we have to have lots of data and hopefully good data so that we can use it to train algorithms that will enable us to make predictions about the future. It will help to come up with a definition of what AI is. So according to Arthur Samuel, this was a definition that he coined in 1959. Artificial intelligence is a field of study that gives computers the ability to learn without being explicitly programmed. So one fundamental difference between artificial intelligence and computer programming is this idea that we are really not hard coding the rules in our code. In other words, we provide an AI system an input, and then without being explicitly programmed, it will provide us an output. And we will have the opportunity to look at examples like that. So it's good to keep that definition in mind. And also in terms of the importance of AI, so according to McKinsey Global Institute, AI is estimated to create $13 trillion of value annually by 2030. So you can see that AI is really expanding at a rapid rate. So AI today is creating lots of value in the software industry. However, AI also is creating great value in other sectors, including retail, travel, transport, telecom, healthcare, and then finance. Shortly, I will be sharing with you some applications that we can build in these different sectors using AI. Okay. So almost all the progress in AI is in the area of artificial narrow intelligence. But here I want to just take a moment and basically share with you a couple of ideas. So here we have AI, and then what we usually want to do right now is to basically talk about just a couple of concepts. One is called artificial general intelligence, and the other one is called artificial narrow intelligence. Artificial general intelligence is this idea that we want to build AI systems that can do anything that humans can do. If you notice, with respect to human intelligence, a human can do several tasks. They can attend a lecture, they can walk, they can eat, they can do so many different things. When we talk about what we call artificial narrow intelligence, is basically a kind of AI which focuses on performing only a specific task. Let's take an example of a bank, for instance, that wants to automate the process of loan approval, right? So banks make money by basically providing loans and getting interest on those loans. In traditional banking, somebody would take the information about an individual or an institution that could include the credit rating, the income, and so on, and make a decision, should we give a loan to this person or not, or to this institution or not. That particular prediction is something that we can do today successfully using AI, but it's focusing on one particular area, which is banking, right? So that same algorithm is not going to work in another area like in real estate and so on, because it's been trained mainly with banking data. Lots of progress that we did today is in the area of artificial narrow intelligence. Unfortunately, AI also refers to another type of AI called, again, AGI, which is this idea that a computer can do anything that humans can do. We haven't really made much progress in this area. You probably have seen some science fiction movies that talk about some concepts around this. That's still just like really science fiction. We don't have yet systems that use AGI. So, but the vast majority of the work is in the area of artificial narrow intelligence. The rise of AI has been driven largely by one tool called machine learning. And then the most used machine learning is called supervised learning. And essentially, when we talk about supervised learning, which is, again, an area under machine learning, which is also under AI, because we talk about the fact that AI, it encompasses or it includes several things, but machine learning is really focusing on specific areas. And basically, when we think about machine learning, we are thinking about narrow artificial intelligence. And in supervised learning is a type of AI where we have what we call A to B mapping. So A would be the input, and then B would be the output. So let's look at some examples of supervised learning. For instance, we have an email, and then we want to predict based on the content of the email, is this a spam or what we call ham, or is this a good email? Or for instance, the input could be an audio, and then the output would be a transcript. In other words, the input would be an audio, and then the output would be a text. There's a typo in here. So we can have an image. Instead of user info, it should be the radar info. And then based on that information, we want to predict the position of other cars. So this is very useful and very helpful in the case of self-driving cars. So in self-driving cars, they need to know or predict where is the position of other cars to be able to properly navigate. In the area of advertising, you could have an ad and then user info or preferences about a particular user. And then you want to predict, is this user going to click on an ad or not? So that's another example. And in manufacturing, You can have an image of a phone, it can be an iPhone, and you want the AI system to predict, is this a good or defective unit? Yeah, so that's another application of supervised learning. When we talk about A to B mapping, some people could say, okay, I understand that, but practically speaking, what would be A? You know, when we look at the data, what would A represent? So let's say if we have a situation where we have, for instance, only the size of the house, and then we want to be able to predict what would be the price of that house. So in that case, the input would be the size of the house. In machine learning, we call that a feature. And then the output would be the price. And again, in machine learning, we call that a label, right? But the input does not have to be only one variable. So notice we can change this problem a little bit and add to the size of the house the number of bedrooms. And then the prediction that we would like to make is of the price. Or we can flip the problem. We can say, well, here is my budget. What house would I be able to afford with this particular budget? In this case, A would be the budget, and then B would be the size of the house. In object identification, so for instance, you would have an image, and then you want to predict what's the label of that particular image. You can think of an example, for instance, in a company where you have an image of an employee or somebody who is coming in, and you want to predict, is this like an employee or not an employee, or the name of the person based on their image. Also, we can look at some other examples. For instance, you have the user ID you have of a particular product, you have the time, and then you have the price of the product, and B would be the prediction, is that product purchased or not. And we also talked about when we have an image of a phone, and then we want to predict whether it's defective. The other question that we want to ask, why machine learning is taking off now. One thing that I want to point out is with traditional ML systems, and I'm going to talk about that in a moment, performance does not get better with more data. So AI is taking off recently due to the rise of neural networks and deep learning. For this presentation, what we can do is basically think of neural networks the same thing as deep learning. In fact, it is actually the same thing. It's just they changed the name. Probably because deep learning sounds really nice for marketing. But before this category of models, we call them neural networks. Today, we call them deep learning. If we want to basically use neural networks and deep learning and obtain the best possible performance from an AI system, then what do we need? We need two things. We need lots of data, big data, and lots of processing power, GPUs. And as we know, recently, we have an explosion of the amount of data that we have, especially during this pandemic. Also, we have our processing capabilities have grown significantly with the rise of what we call graphical processing units. So that's basically one thing that to keep in mind. But I'd like to take a moment here to explain this concept a little bit further. And I just want basically talk about this idea of performance versus data. So if we want today to build an AI system, and here we have data, and then here you have the performance. If we are using traditional ML, I mean, the whole idea of machine learning or even AI, this is not new. So people have been using models to make predictions like what we call a regression or classification, and I'm going to talk about that also in a moment. But they have been using models to make predictions. Let's say here, if you have data all the way to, let's say, maybe 10,000 records. Traditional ML system will go this way, and then the performance really does not improve with more data. It's as if these traditional ML systems, they don't know what to do with more data. With neural networks, what we are saying, if you are using just a small neural network, you can see similar performance if you have a small data, but the performance improves as you get more data. So this would be like maybe a small neural network. Come up with another example. So for this is a medium neural network, and I think you got the idea. And if it's a large neural network, then you get something like that, large neural network, and then this would be a medium. Okay, neural network. So some people would probably ask the question, why is this important? Well, imagine a case of a bank. If they have an ML system that can predict with very high accuracy whether somebody will be paying a loan or not, or an institution, that means for the bank that they can save lots of money, right? Or they won't be in a situation where they give a loan and then they don't get paid. Or in a medical situation, that's even more important when you have an ML system that can predict with a very high accuracy the diagnosis using like data like X-rays and things like that. So in that case, that is very important and very significant. So what we are seeing right now that with neural networks, if we have lots of data, they can outperform traditional ML systems. I'm going to use this opportunity to just clarify a few more things. When we were talking earlier, we said we have AI, and then we said we have ANI, which is artificial narrow intelligence, and AGI. And then we said that lots of progress, in fact, over 70% of the use cases that we have today is in the area of artificial narrow intelligence. And we said under this, we have machine learning. And then under machine learning, we have several areas. I'm going to just mention one of them. One is called supervised learning. And then there is another area, I'm going to just mention it for the sake of this presentation, is called unsupervised learning. Okay. And then under supervised learning, we have essentially two more categories. One is called classification, and then the other category is called regression. So the question here is, what is supervised learning? Well, supervised learning is this idea that if you know exactly what it is that you are trying to predict, that's called supervised learning. Like say, I want to predict the price of a house, or I want to classify the content in an image, or I want to predict whether somebody will pay back a loan or not. Or in the case, in a medical situation, I want to predict the input could be an X-ray and the output is this tumor malignant or benign. So when we have a clear idea about what the target column that we're trying to predict, that is called supervised learning. And if you notice some of the examples I've mentioned, some of them are in the area of what we call regression, when you are trying to predict a continuous value, like the price of a house or the value of a portfolio, for instance. And then the other area, which is called classification. And I've already mentioned a couple of examples. In a medical situation, when you are trying to predict, okay, is this tumor malignant or benign? So that's an example of binary classification. But classification does not have to be binary. We can have a situation where we can have multi-class classification, where we have an image, and that image could be like a traffic light, it could be another pedestrian or another car, and so on. So in that case, you have multiple classes. And again, most of the use cases that we're working on today in AI are in the area of supervised learning. Unsupervised learning is basically an area in machine learning where we don't have the label. In other words, we don't really know what it is that we are trying to predict. So I'm going to give you an example. So if I take the example of InnoSoft, our company, over the years, thankfully, we have worked with lots of customers, and I might be interested to basically see some patterns in the data. For instance, in my mind, I'm thinking, well, probably most of the customers we have, they are in 4 categories. So they might be professionals, students, corporate customers, or international customers. So what I'll do in this setting is to provide the algorithm the number of categories. In this case, it's 4. And then what it will do, it will go through the whole all the data set, which could be like thousands of records. And within seconds, it will classify each customer in one particular category. Somebody says, well, why is that important? First, when we have a situation like that where we cluster customers in different groups, you could say, wow, that's interesting. Why did it decide to basically put this particular customer in this group? And you go back and you start looking at maybe, are there any patterns in terms of the similarities of the features of these customers? So what unsupervised learning, sometimes what it helps us to do is to find out patterns in the data that otherwise we won't be able to have access to. So that's, and the example I've just mentioned is an area of unsupervised learning called clustering. The first question that we could ask, well, that sounds great. If data is important, and some companies who are just starting out, they would ask the question, how can we acquire data? We can acquire data from observed behavior. For example, in preventive maintenance, you can observe some measurements regarding a particular machine, the temperature, the pressure, and then in this case, you want to predict whether that machine was faulty or not. We can also download data from websites. Today, many governments, they have open data initiatives, including the US government. Even here in GUE, there is some data that's available in the public domain. For instance, one initiative is called Dubai Pulse. Or, an organization could also build partnerships with a particular segment, whether it's the medical field or the manufacturing. And in that case, for instance, hospitals, they can share the data once, obviously, there is some kind of agreement or an NDA that's signed. So that's another way to acquire data. Then let's also talk about the different uses and misuses of data. So taking 3 years to collect data is not a good strategy, right? Because at the rate things are going, we're not going to wait 3 years to be able to build an AI system. So what we want to do is first let IT collect some data and show it to your AI team. And here, this is really important. Notice that this is going to be more like an iterative process where IT will collect some data and then they will share it with the AI team. The AI team will provide some feedback to us to what data to collect and then what kind of infrastructure to build. Notice that just collecting a bunch of data and just throwing it at like an ML or AI team, it's not a good strategy, right? So we want to be able to get feedback from our AI team or data scientists or ML engineers about what kind of data that we should collect. For instance, an AI team could ask an IT team to collect data every minute from a big machine as opposed to every 10 minutes, right? And we've already talked about the fact that we have to have the feedback from the AI team when it comes to data. So, and the other thing also, if we have bad data, there's a concept in computer science, we say garbage in, garbage out. Then our AI will learn incorrect things, right? So we want to make sure that we have the right data. Some people could be asking some questions like, okay, great. I think I have an idea of what machine learning is right now, but what's the difference between machine learning and data science? And what would be the deliverable from each one of these areas? So machine learning typically will result in a running AI system. In other words, when a machine learning engineer completes his or her job, what we expect is an AI system, let's say a real estate company where the agent would put in the features of a particular house, and the AI system would predict what would be the price of that particular house. So we need a running application. Typically, that's the output of a machine learning process. Whereas in data science, basically, we are just trying to gain insight from the data. So the output of a data science project could be like just a PowerPoint presentation, which summarizes the conclusions for executives to act. So in data science, basically, you are trying to use some data analysis tools, maybe some data visualization tools to gain insight from the data, and as a result, produce a report that decision makers could use to take action. So that's the fundamental difference. So what makes an AI company? Well, the first part is, as you probably have guessed, is the idea of strategic data acquisition. We've talked about that, and actually we do have a course. I'm gonna talk about that briefly towards the end of this presentation, where we go through these different steps. So the first step is to acquire data in a strategic manner. And then secondly is to be able to have what we call a unified data warehouse. Because as you know, some big organizations, they can have so many different data sources. So data could be on an ERP system, it could be on a relational databases, it could be on an Excel document. Taking time and making the effort to be able to merge all this data and clean it up and have it reside in a unified data warehouse will be highly beneficial to ML engineers or data scientists. And then pervasive automation. So in the case of AI companies, they are constantly thinking about different processes or workflows, and they are asking the question, how can we automate this? One more thing that I want to mention is that we have the new role in the organization is called machine learning engineer. We can't just expect our IT team to become our data science team or our AI team, because obviously the skill sets that are used in AI, they are vastly different from the ones that an IT engineer would normally have. Some of the skill sets would include basically probability, statistics, statistical models, linear algebra, and so on. So it's a really different kind of skill sets. The other thing also that I want to talk about is this idea of what AI can and cannot do. That's also an important question, right? To set the expectations. So somebody who is a C-level executive, they do need to know what AI can and cannot do to be able to have successful communication or interaction with their AI teams. So anything that you can do with 1 second of thought, you can probably now automate. Something that AI cannot do is to analyze, for instance, a market and produce a 50-page report. We don't have that today. Let's look at this example. We could get this particular feedback like in the situation. Imagine we have a chatbot and we want to be able to handle a request like this that came in from a customer. The shirt arrived too late, so I wasn't able to give it to my brother for his birthday. Can I return it? In this setting, what would normally a chatbot do? AI can recognize that this is a refund request and route it to the right department. Customer service, for instance, based on the words, we can use natural language processing to identify the specific words in the message, and based on that, we can route it to the right department. What AI cannot do is to write back a complicated message sympathizing with this customer. So that's something that AI cannot do today. In this setting, what we can do here is to basically, the input would be a message like this we receive from a customer. The output would be a classification of that message. Is this a refund request? Is this a technical issue? And so on. And then route the request to the right department. As we said, deep learning basically is the area that has revolutionized AI in the last, I would say, 10 or 15 years. So what is deep learning? When it comes to structured data, so we've already established a long time ago that computers are better than humans in general when dealing with structured data. So until recently, humans were better than computers in processing unstructured data. And again, when we talk about unstructured data in this setting, we're talking about images, videos, audio, and so on, or even textual content. What has happened? Well, deep learning has been focusing on solving problems that were traditionally difficult for computers and easy for humans. So until just like 10 years or 15 years ago, you could show an image of a cat to a computer and it wouldn't know what it is. Whereas you can show that same image to a 3-year-old girl and she will tell you that that is a cat. Basically, with advances in algorithms and computational power that we have today has contributed that right now with deep learning, we can gain insight from unstructured data. So basically, that's what deep learning is. And there are many areas that deep learning focuses on, including computer vision, voice recognition, machine translation. I don't know if you've been using a Google Translator. It's getting more and more accurate over time. And so deep learning has revolutionized many verticals, including healthcare, transportation, customer service, and finance. So since we are talking about deep learning, I felt that it would be good to show you just a quick demonstration of what deep learning or neural networks, we're going to use these two terms interchangeably. So let me go ahead and show you what a neural network would look like. So this is an example of what a neural network is. So I'm going to construct a small neural network here. And I will explain the structure in a moment. So this is an example of a neural network. So let's start with the easy stuff. So this part here, we call it the input layer. And this part here, we call it the output layer. Some of you are probably thinking, what problem are we trying to solve? Well, imagine we have a data set like this. And let's say this is data about animals. I happen to like animals, and a couple of animals that we like here in DOE are like camels and horses. And let's say on the x-axis, say the height, and then on the y-axis is the weight of the animal. I'm just giving this as an example. And then this is the data. These are the animals that we have today in our farm or something like that. And then when we plot the data, we see a pattern. So the orange dots, they represent, let's say, the camels, and the blue dots, they represent the horses. So notice we have the data about their features, but we also have the label. We know which animal that is because we know them, right? We have the data because we have these animals in-house. Now, the question is, what if we receive a batch of data where we have only the measurements? In other words, you have the weight and then the height of the animal, and you have no idea whether it's a camel or a horse. And you want to build an algorithm that can generalize this kind of relationship. So in this case, we only really have data. So what we really need to do here is to build a model that will generalize this kind of relationship. So that's basically what this whole part in the neural network is all about. It's called the hidden layers. So this is where the model will get constructed in such a way that we will be able to predict for every point in this space, based on this data, whether it's going to be of type horse or animal. And incidentally, this is a classification problem. So let me go ahead and run this. So this is the model that we have. So if we have, for instance, a measurement like this in this area, then we would predict that that's going to be a camel. If it's in this area, it would be a horse. Actually, you see this white area. Actually, there is no white area. There's only two classes, camels and horses. So this is just a design, user interface design. So that's an example of a neural network, and this is really where the magic happens right here. We can also look at more complicated data set if you want, and one thing that we can do about neural network is we can tune them. For instance, again, I'm not going to get too technical here, but we can play with what we call the activation functions. We can play with the learning rates, and we can apply what we call a regularization and so on. If you are interested to learn it, we definitely have courses. We have a deep learning course that will help you to do that. So that's another example where we are trying to build a model, again, based on this data set to predict whether an animal is in a class A or class B. I think you got the idea. So what I can do now is I can continue the remaining slides. Yeah, so we talked about some of the concept of deep learning. So one thing that to keep in mind about deep learning is we have an input layer, and then we have an output layer. So in this case, we are solving a classification problem. But we could also have a situation where the input could be, for instance, different features of a given house, like the size of the house, the number of bedrooms, the location of the house, and the output would be a price. And in that case would be a regression problem. And what we noticed about deep learning, it outperforms basically all other algorithms when it comes to working with unstructured data. So it's really doing well when we are trying to make predictions based on images, on videos, and so on. I mentioned a project that I worked on with my colleagues at Stanford. It was a self-driving cars where the input, they were pictures from Beijing, China, and then the output would be basically how many lanes are on that picture. So in that sense, the input actually is a picture, and the output is what we call a mask, which basically identify the lanes on that particular picture. And someone could ask the question, why is that important? Well, if we are in a self-driving car, needs to know how many lanes are on the road and which lane the car is on. Just want to finish this basically by saying a few things about how can we go ahead and integrate AI in our firm. So basically, there is a playbook that we can use. So there is a process to do this. First part is to execute pilot projects to gain momentum, build an in-house AI team. That's also important. and provide AI training, not just to the engineers, but also to the managers, because that way they can have a successful communication, develop an AI strategy, and develop internal and external communication playbook. I mean, of course, here I'm just giving an overview. We have a course which going to span over a period of 4 weeks, especially it's going to be on Saturdays, which basically covers AI for managers. And they will share with you the link in a moment if you want to learn more about this. That leads me to basically the final part of the presentation. Basically, industries have been and will continue to be disrupted by AI and deep learning. Learning AI, deep learning, and big data is not easy. We have, as I mentioned, AI for Decision Makers program, which will enable you to gain the skills to be successful in the new AI economy. And then you can also learn the best practices and methodologies in conducting AI projects. What we are planning to do during the course is to invite industry experts who have implemented AI to share also their experience and their views.